Welcome back, everybody. And today we're going to be solving exponential equations with logarithms. And you may want to have nearby for reference your "what is a log anyway" notes, because it's got this handy thing in it right there. So you may want to have that available for yourself. So solving exponential equations with logarithms. Open that up, and we have just a reminder of the exponent rules and the log rules. You may need them in order to simplify some of your equations, but we'll get there. And then, of course, we've got a reminder of what is e, what is the natural log, etc. So I have some good news for you. You already know how to do everything on here. To solve these equations, you'll use reverse PEMDAS. And then once you get to the exponent step, you're just going to convert your exponent into a logarithm, just like so. So taking our example, step 0, if you can combine any like terms, go ahead and do that. In this case, we don't have any, but sometimes you will, so just something to look out for. All right, so then we're going to do, why did I write that P so big? I'm going to do reverse PEMDAS. Put it here. Okay, so first add or subtract anything. Yeah, I can add that 4. So let me rewrite that. So I have 6 times 3 to the power of 5x minus 6 minus 4 equals 50. So I'm going to add 4 to both sides. So 6 times 3 to the power of 5x minus 6 equals 54. Divide by 6. Okay, so I did add, subtract. I'm doing multiply, divide. So 3 to the power of 5x minus 6 equals, that's a 6, equals 9. Okay, so now I am indeed at my exponent step. So you should now be at your exponent step. To undo a power of x, write your expression as a logarithm, or log. So you may want to have this back. So remember, you're going to take your base and make it the subscript, the base of your log. Your exponent is going to end up on the right side. And your product, or your answer, so to speak, is going to end up as the argument of the log. So let's kind of have both visible there. So I have log base 3, so base 3 of 9. So 9 is on the right hand side all by itself, so I want 9 here. So log base 3 of 9 equals, and then you get the exponent there on the right hand side all by itself. So 5x minus 6. Now this right here has no variables in it, so you can just put that in your calculator and see what you get. Now that part you could probably just do in your head. I mean, that means 3 to what power is 9, and we know it's 2, but let's go ahead and practice typing it. So press Control and the 10 to the X button. Log base 3 of 9, we know it's going to be 2 because 3 squared is 9, but go ahead and practice typing it in, and oh look, it's 2. So replace this whole thing here with 2 equals 5x minus 6. And once you have that, you are done with the exponent step, and you're now in the parentheses, so you get to start all the way back at the bottom again. So, is there anything I can add or subtract now? Oh, there sure is. I can add 6. So 8 equals 5x, and then finally divide by 5. And x equals 1.6. So you may want to check that answer. So I get 6 times 3 to the power of 5 times 1.6 minus 6 minus 4. I want to see if that gives us 50. Okay, so 6 times 3, can't see it, to the power of 5 times 1.6 minus 6 minus 4, indeed gives us 50. Awesome. So let's check out these last two here. And then in class, we're going to do some practice with this as well. All right, so number 1, reverse PEMDAS. Can I add or subtract anything? Well, sure I can. I can subtract 3. Then 9 to the power of n plus 10 equals 78. Okay, now some kids try to then divide by 9, but you have to remember that I'm not taking 9 times n plus 10. I'm taking 9 to the power of n plus 10. This is an exponent. N is in the exponent. So there's actually nothing here I can divide by. So I'm now on my exponent step, which means I need to convert it to a logarithm. So you want to have this in front of you. So take the base of your exponent and make it the base of your log. Then take the right-hand side and make it your argument. And then take your exponent and put it on the right side. And then this shouldn't have any variables left in it anymore, so you can just put that in your calculator. So log base 9 of 78 gives me 1.9828. 1.98282 equals n plus 10. And then finally subtract 10. So you get n equals negative 8.017 because we're rounded to the third decimal place. And then I recommend at first at least checking your answer. So 9 to the power of negative 8.017 plus 10 plus 3, and let's see what we get. We should get approximately 81. It may be off because we had to round a little bit, but it shouldn't be too far off. And I do get approximately 81. So I actually got 81.0302, but it's within rounding error considering what we had to do to the exponent, so we are good.